Welcome back. Today we are discussing another special kind of factoring. This kind of factoring is done when we have a sum of two cubes. That means we have two terms that are cubed added together. So in this example, we have x cubed being added to 5 cubed. X cubed being added to 5 cubed. Now you may not have noticed right off the bat that that was 5 cubed, but if in your calculator you try to find the cube root of 125, what you would get is you would get 5. So 5 times 5 times 5 is 125. Now, another kind of factoring that we have is a difference of cubes. And of course, that's when two cubes are subtracted instead of added. And an example of that we have would be x cubed minus 5 cubed. So in both cases, we either have two cubes added together or we have two cubes subtracted from one another. Let's get into how to factor these special kinds of expressions. All right, so when we have an expression that is a cube, like this x cubed here, plus another cube, like this 5 cubed here, we're going to use something called the sum of cubes formula. The sum of cubes formula is a plus b times a squared minus ab plus b squared. Now you may not know what any of these are, which is okay. I'm going to explain how it works. What we have to do is we have to define a, we have to define a squared, and a cubed. Likewise, we have to define b, b squared, and b cubed. Now remember how in the previous slide I said that a sum of two cubes is a cubed plus b cubed? The good news here means that we already have a cubed and b cubed. A cubed is just the first cube you see, x cubed. B cubed is the second cube you see, 125. All right, so we have our a cubed and our b cubed, and we got them straight from our expression. Our a cubed is our first cube, our b cubed is our second cube. Next, what we need to do is we need to find a and b. Now, a is pretty easy to find. All you need to do is drop the cube. So if you want to get from a cubed to a, just drop the cubed on the x cubed and you get x. B might be a little bit harder because we're dealing with a number. And there's two ways you could do this. In your calculator, you could do the cube root of 125 and you would get 5. Now, some calculators don't let you do a cube root like this. So what you're going to have to do is you're going to have to put 125 to the power of 1/3. 125 to the power of 1/3, and that will give you the same thing. If your calculator lets you do this first one here, don't worry about what I said below. But if your calculator doesn't let you do what I just underlined in red, you're going to have to do 125 to the power of 1/3. So now that we know what a and b are, we need to find a squared and b squared. Well, a squared is just a, which we said was x, but with a square on it. B squared is just b, which is 5 squared. What's 5 squared? That's 5 times 5. What's 5 times 5? 25. All right, so now that we have all of this information, we're going to plug it back into our formula. So our formula, again, is up here, underlining it in green now. A plus b times a squared minus ab plus b squared. So let's set up our parentheses. We're going to have an a plus a b. And then we're going to have an a squared minus an ab plus a b squared. Why don't we go ahead and put our signs together? So the sum of cubes formula says our first sign is a plus, our second sign is a minus, and our third sign is a plus. Then we have to put a in first because it's a plus b, so a goes first. We get our a from right here, underlining it in blue now. We get our a from right here, and then we get our b from right here, underlining it in blue over here again. So we get our b from over here. Our b is just 5, so x plus 5 is our first factor. Then we need to look at our a squared minus ab plus b squared. Well, a squared we have right here. I'm underlining it in the orange. A squared is just x squared, so we're going to put that where a squared is supposed to go, right there. Then we have minus a times b. Well, a times b would just be a, which in yellow here, a times b. So what's x times 5? X times 5 is just 5x, right? Then we need b squared. B squared is 25, and I'm getting that from over here, 25. And so we get our factored form to be x plus 5, x squared minus 5x plus 25. Can we factor the second part of the expression any further? Well, let's see. Are there two numbers that multiply to be 25 and add to be negative 5? The answer would be no. So we are done. This would be our final answer for the expression. So what if instead of a plus separating our cubes, we have a minus? We're going to use a slightly different formula called the difference of cubes formula. And the difference of cubes formula says a minus b times a squared plus ab plus b squared. So if you compare this formula to the formula on our last slide, you'll notice the only difference is this minus here and this plus here. The signs changed for those two. So here we're dealing with a cube minus a cube. We're dealing with x cubed minus 125. So we're dealing with something in the form of a cubed minus b cubed. So let's go ahead and let's find a squared. Here, let me fix that a real quick. Squared, a cubed, b squared, and b cubed. This is very similar to what we did last time. We found all parts of our formula, right? Now, the expression already gives us the cubes on the bottom here. A cubed is just that first term in the x cubed minus 125. The first term is x cubed. So just in case you're wondering where I'm getting it from, I'm getting it from right here. That's going to be your a cubed. Your b cubed is going to be right here in the purple, that 125. The b cubed is what comes after the minus in a difference of cubes. So we have our b cubed. Now we need to find our a and our b. We need to go back up to the top. So a is just a cubed without the cube. So just write the x, no cube. B cubed, when we want to get it from b cubed to b, when we have a number, we have to find the cube root. So you can, in your calculator, either find the cube root of 125 or just do 125 to the power of 1/3. And what you get would be 5. So we found our a and we found our b. Now we need to find our a squared. A squared is just a, but with a squared. B squared is just b, but squared. So 5 times 5, 25. Let's go ahead and plug it into our formula. So this time we have a minus here, and we have two pluses here. First things first, we need to go ahead and find our a. We said that a is x, and I'm just getting that from the chart that we made on the side. The a squared, a cubed, b squared, b cubed. So a we said was x. And then we said that b was 5. So a minus b, I'm replacing that with x minus 5 because we said that a is x, and we said that b is 5. Next, I need to replace a squared with what a squared is. We said that a squared was x squared, right? We said a squared was x squared, so I'm going to replace that with what it is. Then a times b is going to be x times 5. X times 5, which is just 5x. And then finally, b squared we said was 25. I'm getting that from right over here. B squared is 25. That is it. We end up with x minus 5 times x squared plus 5x plus 25. And because in this second one here, sometimes you can factor the second factor further. But to factor this further, we would need two numbers that multiply to be 25 and add to be 5. I don't believe that there are any, so we are done. Alrighty, so we're going back to sum of cubes because we have a cube here, a plus here, and another cube here. But what makes this different is instead of just being an x cubed plus another cube, we actually have something cubed in front of the x. So our a cubed plus b cubed form is still there, but when we write our chart, our a equals a squared equals, that should be a cubed. A cubed equals our b squared, our b cubed. Well, what we have that's different is a cubed is not just x cubed anymore. A cubed is this whole thing, 27x cubed, right? B cubed, of course, is still just 64. It's just what comes after the plus or minus, depending on if you're doing sum of cubes or difference of cubes. But when we're getting from a cubed up to just regular a, we have to drop the cube on the x, but that's not all. We also have to drop the cube on the 27. To drop the cube on a number, you have to find the cube root. You have to find the cube root. And if your calculator won't let you do that, just do 27 to the power of 1 divided by 3. And what you'll get is 3. So to drop the cube on a number, we take the cube root and we get 3. I'm going to erase this so that I have more room. Next, we have 64. Again, we got to drop the cube on the 64. 64 is 4 cubed. Again, if we do the cube root of 64, we get 4. So 64 is 4 cubed. So b, regular old b, is 4. To get from a to a squared, we have to square our a. 3 squared is 9, and x squared is x squared. To get from b to b squared, we have to square our b. 4 squared is 16. So, just in case you forgot, our formula for sum of cubes is a plus b times a squared minus ab plus b squared. So what we're going to do is we're going to go ahead and we're going to form our parentheses, and we're going to form our signs. So we have a plus, we have a minus, and we have a plus, and that comes from the formula. A, we said that a was 3x. I'm just getting that from the chart we made earlier, 3x. B, we said, was 4. A squared, we said, was 9x squared. AB, well, AB is just going to be this times this. A times B. So what's 3 times 4? 3 times 4 is 12. And there's an x with a 3, so we got to attach an x here. Finally, we have b squared, which we said was 16. Now, earlier in a different video, I talked about factoring trinomials when a is not 1. Sometimes this trinomial that's created here is factorable, and you would have to factor it further. Now, if we were to try to factor it and multiply the 9 times the 16, we'd get 144. I can already tell you that there are no two factors that would multiply to be 144 and add to be negative 12. So we cannot go any further. We are done. This is the factored form of the problem shown in the question. Alrighty, one more question. This is another difference of cubes, and I can tell that it's a difference of cubes because we have a cube here, we have a subtraction sign here, and we have another cube here. Now, this one's a little bit pesky, I'm not going to lie. A lot of people may think, why is 1 a cube? Well, the reason that 1 is a cube is 1 is also a square, it's a cube, it's a fourth, it's a lot of things because 1 times 1 is 1, so 1 squared is 1. 1 times 1 times 1 times 1 is 1, so 1 cubed is 1. 1 is a lot of things. So whenever we write our chart, a squared, a cubed, b, try this one on, think about this one on your own. What is a cubed here? If you said that a cubed was 8x cubed, you'd be correct. We take that entire first term and we let it be a cubed. B, we take that entire second term and we let it be b cubed. So the second term is just 1. All right. Now what we need to do is we need to drop the cubes on our a. Dropping the cube on the x is pretty easy. We just go from x cubed to x, right? The 8 is a little bit more difficult. If you don't know what the cube root of a is off the top of your head, you can do it in your calculator. What you'll get is 2. So 2 times 2 times 2 is 8. What about 1? You could do this one in your calculator if you want to, but think about it this way. 1 times 1 is always 1. So if we want the cube root of 1, well, how do we get to 1 from 3 numbers multiplied by themselves? That would be 1 times 1 times 1. So the cube root of 1 is literally just 1. So b cubed is 1. B is also 1. I know, it's a little pesky. It's a little tricky. So next, we go from a to a squared. To get from a to a squared, we have to square our 2, because our 2 is in a, so 2 squared is 4, and we also have to square our x. So 2x, we square that x to be x squared. So we get 4x squared for our a squared term. B, what's 1 squared? Well, 1 squared is 1 times 1. It's just 1. Now we need to remember our difference of cubes formula. Very similar to sum of cubes, but with a minus to begin with, and 2 pluses in our trinomial. There. Ooh, oh, that's very ugly. Here, let me fix that. There we go. All right, so let's go ahead and let's set up our new parentheses and signs. So coming from the difference of cubes formula, we get a negative sign here, we get a positive sign here, and we get another plus there. Now we need to go ahead and put it together. What did we say that a was? Well, we said that a in our chart was 2x. That is a tiny 2. Make it a little bit bigger. 2x. Then, of course, we take away b. b is 1. Then we have a squared. a squared we said was 4x squared. Then we have a times b. Well, a is 2x and b is 1. 2x times 1 is just 2x. Finally, we have b squared. Well, b squared is just 1 squared. That's 1. Let's see if we can factor this trinomial we made here any further. Let's go ahead and let's do 4 times 1. 4 times 1 is 4. So AC is 4. So we need 2 numbers that multiply to be 4 and add to be 2. 2 numbers that multiply to be AC and add to be B. And the fact is, we're not going to find any because they don't exist. We're not going to find 2 numbers that multiply to be positive 4 and add to be positive 2. So we are done. If you found this video to be helpful, please like and subscribe. Thank you so much for watching. We're going to have some more content coming out shortly.